Hello everyone, welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. This is Sanjay Rathi and we are going to start basics of analog. As you know, analog is one of the important subjects for all competitive exams, whether it is GATE, Engineering Services, ISRO or DRDO. And this is a summer special series and we are making this summer special with what? Basics of analog. That is for GATE 2024. And this is a Super 3 series where I am going to discuss what basics of network, basics of digital and basics of what? Analog, guys. Let me know that sound quality, picture quality, everything is fine. First of all, yes, please. Everything is fine now? I think. Okay, I think now everything is fine. Okay. So before this series, before this session, I have taken one session on basics of network and then one session on what about the books, standard textbook. So please watch that session so that you will get the idea about the standard textbook, weightage of the subject, and what about the importance of this subject, important topics, everything. Okay, and then analog. In this session we will discuss what syllabus of the analog and what are the important topics, and then we will cover basics of diodes. Okay, and tomorrow we will discuss important numericals questions on what? Diodes. Okay, now guys, so before starting the session, this is important information. BYJU'S Premier League BPL for electronics, electrical and computer science branch. This is a YouTube plus app series. It is starting soon on our channel. Here we will give you the theory on what YouTube, and then you are going to solve the quizzes on our BYJU'S exam prep app. Please install the app now. Okay, so Aberi Chakravarti, very good evening. Lokesh, how are you? Okay, so please ask your friends to join the session now. Sailaja, very good evening. Then guys, take a step towards success in GATE. This is a golden opportunity for you. Give the national scholarship test for GATE examination and get up to what? 90% off on our program. Please note that time and date, 25th June, means this coming Sunday at 9 AM sharp. So register now for this scholarship test. Okay, then how to get that GATE 2024 means strategy to be in top 1% in GATE 2024, guys. Okay, and that is the free workshop live interactive session by Richa Gupta ma'am, 27th June at 7:30 PM, means on coming Tuesday, guys. So on 25th give the scholarship test, on 27th get the idea about the how to ace the GATE, and that is the strategy to win top 1% in GATE 2024. And you can also ask your doubts here. Then now I am going to start the syllabus. What are the important topics here? What are the important topics from the analog, guys? So what are the important topics from the analog? That is the diode circuit. As you know, just quickly I am going to discuss the syllabus. Till then, please share the link of the session then. Okay. Give me 1 minute. Okay, guys. Now, that is the important topics from analog. Diode circuit means application of the diodes: rectifier, filter, precision rectifier, clamper, voltage doubler, clipper, and clamper by using operational amplifier, that is also called active clamper. To get the command over that. Then voltage regulator by using the voltage Zener diode. Then next important topic is transistor biasing and stabilization, current mirror circuit. BJT at low frequency, BJT at high frequency means amplifier by using the BJT. And we are having the three analysis: low frequency analysis, high frequency analysis, and what? Mid frequency analysis. And you heard about the hybrid parameters, RE model, T model, right, or pi model. So this is the case. Then BJT at high frequency, multi-stage amplifier and differential amplifier. Again, this is an important topic. Here you will learn about the cascade amplifier, right? That is the common emitter followed by the common base, Darlington pair, common collector followed by the common collector. Then differential amplifier, that is called emitter coupled differential amplifier, and that is important to understand the concept of operational amplifier. Now, after that, low and high frequency analysis of FET, you should follow this sequence. Then feedback amplifiers, voltage series, voltage shunt, current series, current shunt, feedback. What are the advantages of negative feedback? What is the use of the positive feedback? And everything about the feedback. This chapter is very important. Guys, this is not mentioned in the syllabus of GATE, but try to understand. We can solve some questions quickly within 10 seconds or 20 seconds by using the concept of what? Feedback. So remember, this topic is not mentioned in the syllabus of GATE, but it is important. Get the idea about the voltage series feedback, voltage shunt, current series and current shunt, and get the short tricks. Then oscillators, sinusoidal oscillators, power amplifiers. This power amplifier is important for all competitive exams, ISRO, DRDO, right, and engineering services pre and what mains, class A, class B, class AB, class C, push-pull power amplifier. Then finally, favorite topic, your operational amplifier. Waveform generator means bistable, monostable, astable multivibrators, and linear wave shaping circuit means high pass RC circuit and low pass RC circuit. This is the low pass RC circuit and this is the high pass RC circuit. And analog, completely based on these two circuits, high pass RC and low pass RC circuit. How? You will get idea with me, right? So please start your session, start your journey with us, start your preparation for GATE 2024. Okay, don't wait for the right time. Now this is the right time. Quickly start your preparation. Then this is the syllabus, and that's why, because three subjects are linked, network plus what? Digital and what? Analog. You can start your preparation with these three subjects. If you are new in the field of GATE examination or in the field of what? Technical, then start your preparation with these three subjects: network, digital and what? Analog. Concept of network will be used in what? Analog, and then analog will be used in what? Digital. For example, A to D, D to A converter in logic families, and how to design the gates by using the diodes and by using the transistors, by using the MOSFET, by using CMOS. So that is the case. So these are the series. So on 17th June, from 17th June, I have taken the series. Please take the screenshot of that. Now already I have taken one session on syllabus, then basics of network, then KCL, KVL, mesh and nodal analysis. This is the third one, and finally up to 27th June I have sessions on digitals. Then we will discuss the previous year questions of network and digital, previous year questions of what? Basics of analog, guys. Okay, so that you will get the idea and you can start with full confidence. Okay, these all are what? Very conceptual subjects. Okay, then finally guys, अब आपको आएगा कि सर आप कौन है. So this is my small introduction. Myself Sanjay Rathi. I am having around 22 years of teaching experience. I have qualified and selected for engineering services exam multiple times. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008, and I have trained more than 1 lakh students for these competitive exams. तो पूरे एक्सपीरियंस के साथ मैं आपको बता दूं, अभी भी आप अपनी प्रिपरेशन स्टार्ट करते हैं तो आप गेट में टॉप रैंक ला सकते हैं. किसी से और से कंपेयर मत कीजिए, अपने आप से कंपेयर कीजिए एंड स्टार्ट योर प्रिपरेशन नाउ. This is a series on app daily at 11 AM morning on BYJU'S exam prep app. Install the app. I am taking session, expected question from network, expected question from digital, expected questions from analog, and tomorrow I am going to conduct what? One quiz. If you are interested, then join that and check your preparation for ISRO examination, ISRO 2023. Anyone can join, because here we will solve the questions from network and digital, and then we will solve questions from analog. That is at sharp at 11 AM, and we will provide you what your score, what is your rank among the students. Yes, it will boost your confidence. Okay, now tell me, what is the, if any idea about the diode? You have started the preparation of the diodes, you have learned something about the diodes, yes or no? Kyo Gunji, Naveen Kumar, Roman, Sailaja, Aberi, Lokesh. And today it is a yoga day, International Yoga Day. So happy Yoga Day, guys, and start giving the 10 to 15 minutes for what meditation and what yoga. It will concentrate your energy and you are going to get the top rank in all coming examination. It will help you. Now this is the diode, guys. Today I will give the basic idea about the diodes. What is the diode actually? And then we will solve what some important numericals on the diode. Tomorrow we will solve some numericals on diode. So what is the diode? Actually it is a PN junction. Actually it is a PN junction and very important component to understand the concept of analog. This is the P type, this is the N type, P type semiconductor, N type semiconductor. Here we are having the metallurgical boundary. This is called anode terminal, this is called cathode terminal, and that is the symbol for the diode. Current will flow from P side to N side. That's why this is arrow is represented that give the direction of the current actually. And this is the PN junction. Now, we are giving Na type doping here. That is called acceptor. Here we are giving the donor type impurity. It will accept one electron and it will create holes. When it will accept an electron, it will become negative ions. Negative ions. Here it will donate one electron and become the positive ions, and that's why the donor ion is positive ion. And acceptor ions is what? Negative ions. This is the hole and that is the electron. This will become P type and that will become N type. So this is the basic idea. Now, all in one, very good evening. Now guys, diodes. Right, and last year in electrical engineering, this year 2022, very conceptual questions from what? Diode, guys. So tomorrow we will discuss those questions, but get the basic idea about that. So when I am talking about the diode, then first of all, ideal diode. First of all, ideal diode. Ideal diode means there are two conditions. If we are giving, this is called positive terminal voltage and that is called negative terminal voltage. Remember, if the positive terminal voltage is greater than the negative terminal voltage, means we are providing the high voltage at this point, low voltage at this point, then that diode is forward bias. Then the diode is forward bias. For example, this is 4 volt, this is 3 volt. Diode is forward bias. We are providing effective voltage, there will be the connection of the resistors and so on. Then suppose it is ground, here you are going the 5 volt, again the diode is forward bias. Then here minus 3 volt, this is the minus 2 volt. Again, this is the minus 2 is greater than minus 3, again the diode is forward bias. Remember guys, once the diode is forward bias, it will ideally act as what? Short circuit. Ideally, it will act as short circuit and it will allow the current from P side to N side. And always remember, when the diode is forward bias, the current will be greater than or equal to 0. It will not allow the current in reverse direction from negative to positive terminal. I am talking about the ideal diode. Okay, Gunjan Naveen, you are not getting the notification of the class in the Telegram. I have sent the notification. Na? Yes, I think I have sent the notification. On which channel? On join my Telegram channel, that is Electronics by Sanjay Rathi. Electronics by Sanjay Rathi, and where I have sent the message, everyone. Right? So this is the Electronics by Sanjay Rathi. Okay then. Now, this is the forward bias. Similarly, forward bias means always remember the current will flow from P side to N side. When we are making this is the Vn and Vp. When Vn is greater than Vp or Vp is less than Vn, diode is reverse bias. Means suppose you are connecting ground, here you are connecting 3 volt. It is a reverse bias. You are connecting the 4 volt here 3 volt. Again it is a reverse bias. You are checking that the voltage at this terminal is what? Minus 3 volt. Voltage at this terminal is minus 5 volt. minus 5 is less than minus 3. That's why this diode is again reverse biased. Minus 3 is greater than minus 5 volt. This diode is what? Reverse bias. Under ideal condition, it will act as what? Open circuit. And it will not allow the current 0. And what is the resistance? Infinite. Resistance is infinite. In reverse direction, resistance is infinite. In forward direction, resistance is what? 0. So when we are talking about the characteristics, so everyone, as you know, the diode is a non-linear device. Diode is actually what? Non-linear device. But when we are considering under ideal condition, diode become what? Diode will become what? Linear device. How it is converted into linear device? Because in two regions. In a two region means, for example, when it is forward bias, it has a constant resistance, that is called RF. And ideally we are saying that it is short circuit. So RF is 0, means it has the constant resistance. Similarly, when it is reverse bias, again it has the constant resistance RR. Normally it is in the range of what? Mega ohm. This is in ohm. But under ideal condition we are saying that it is open circuit. So we are assuming, because it has the constant resistance for forward bias and the constant resistance for the reverse bias, then we can say it is linear in two reasons. Forward bias, it is a linear device. Reverse bias, it is a linear device. It is called piecewise linear model. What is the name? Piecewise linear model, guys. What is the piecewise linear model? Now watch this. For reverse direction, that is the case. We are increasing the voltage, but there is no change in the current. For forward direction, we are increasing current, but there is no change in the voltage, and that is called the characteristics. Okay. Here, this is I, this is what V. That is the characteristics for ideal diode. And it has constant resistance for forward bias, it has constant resistance for reverse bias. And we are solving the questions. So number of questions are based on what? Ideal condition. Number of questions are based on ideal condition. Now, I will ask one question, then try to solve this question, and then again we will solve some more questions on that. Very, very easy question. Tell me guys, what about this diode? Forward bias or reverse bias? Everyone. Very, very easy question. This is the 10 kilo ohm. This is 10 kilo ohm, right? And this is 15 volt. This is 10 kilo ohm. Tell me, what is the current through the diode? I not. And what is the status of the diode? Forward bias or reverse bias? Yes, Lucas. What is this? Forward bias or reverse bias? Everyone. So this is a very simple. Under ideal condition, when it is a 15 volt is connected here, it is towards the positive side. So normally we are thinking that this diode is what? Forward bias. Because of that 15 volt, because there is no battery, then that diode is forward bias. Under ideal condition, this diode will act as short circuit. Then this is a very, very simple question. It will act as short circuit and it will allow the current. Then use the concept of network. Network and analogs are what? Related. Once the diode is short circuit or once the diode is replaced by the resistance or battery, in the terms of battery, now that is the question of what? Network only. So network means what? This 10 kilo ohm, this 10 kilo ohm, this 10 kilo ohm, this is a 15 volt. This 10 kilo ohm and 10 kilo ohm are in parallel, this 10 kilo ohm, that is in series. So what is the total resistance here? 5, 10, 15, so 10, 15, this battery will give the 15 divided by 15, 1 milliampere current. Because it is in kilo ohm, the current will be in milliampere. Now here you are getting the 1 milliampere current and we are having the 10 kilo ohm voltage current division rule, equal current. What is the equal current here? The current will be 0.5 milliampere, here the current will be 0.5 milliampere. current division rule. So we are using the concept of what? Network here. So you will get 0.5 milliampere current through the diode. This is the diode. It will allow the current in this direction, 0.5 milliampere. 0.5 milliampere. And if it is asked what is the current given by the battery, 1 milliampere. What is the current through the diode? That is the 0.5 milliampere. Very easy question. Very, very easy. And that is on what? Ideal diode. That is on ideal diode. And now this is the first diagram. Already we have solved one question on that. Tomorrow we will solve more and more questions on that. Simple diode circuits. Right? Next one. Next thing is, this is called piecewise linear characteristics. Okay? Piecewise linear characteristics. Now, when I want to solve another question, another diagram on that. Okay. That is the case. Second case. Now, this is the plus, this is the minus. Again, it is a forward bias. Under practical condition, the drop across the diode is what? 0.7 volt for silicon. 0.7 volt for silicon. So this is what? It is replaced by a battery of 0.7 volt for silicon. Or under reverse bias condition, this is called reverse bias. Again, it will act as what? Open circuit. Sometimes this type of diagram will be given in the question. Then what is the meaning of this? This has this type of characteristics. Right? Then up to 0.7 zero current, and after 0.7 the current will increase, but the drop across the diode is fixed. Drop across the diode is fixed. That is the 0.7 volt. This is the drop across the diode, and that is the current I. Right? And that is the value. Now guys, I am giving the same question, and please give me the answer. What is the answer for this question? What is the answer for this question? I am giving the same diagram. That is the same diagram here already. But this time the diode is what? Practical diode. We will solve this question. Okay? We will solve this question for new characteristics. Practical characteristics. Okay. That is the characteristics. That is given in the question. 0.7 volt is the drop. When the diode is forward bias, reverse bias, it will act as open circuit. Now, this diagram will not work. This will not work. If this is a practical question, first of all, watch this. 15 volt, because of that 15 volt, the diode is forward bias. Once the diode is forward bias, then it is replaced by a 0.7 volt battery. .7 volt battery, and that is the resistance. 10K, 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 and what? 15 volt. This is the case. This is the 0.7 volt battery. Now guys, what is the current through the diode? If this is the question. So guys, get the equivalent circuit. Again, you have to apply what? Network. So if you are not having the command over the network, then how we can solve this question? Tell me, which method is better to get the current now? Initially, we have find the R equivalent and the current division rule. Now this time, because we are having the 0.7 volt battery, and we can change the position of 0.7 and 10 kilo ohm resistor, you can apply the KCL at this point, Vx. When I want to find the Vx at this point, then apply the KCL. Vx minus 15. Vx minus 15 divided by 10 plus Vx minus 0 by 10 plus Vx minus 0.7 divided by 10 is equal to what? 0. So what are the outgoing currents? Yesterday I have given you the idea about the KCL or nodal analysis. This is the I1, this is the I2, and this is the I3. And your I3 is nothing but I. What is the I1 plus I2 plus I3 is equal to 0. So Vx minus 15 by 10, Vx minus 0 by 10, Vx minus 0.7 divided by 10. So you can take 10 as the LCM and it will become 0. So it will become Vx plus Vx plus Vx, 3Vx is equal to 15 minus 0.7. So what is the Vx is equal to 14.3 divided by 3. 14.3 divided by 3, that is the value of the Vx. That is the value of the Vx. Okay. 14.3 divided by the 3. Once you will get the Vx, what is the I? I is nothing but I3. Now you can find I3 or I, current through the diode. Vx minus 0.7 upon what? 10 kilo. Now you have the value of the Vx, then you can put the value of the Vx and then you can find the I. 14.3 divided by 3 minus 0.7 upon 10. And that is the value of what I. Now use, if you know what is the answer, everyone please give me the answer in the comments box. So guys, tell me, new students, tell me, once I am replacing the diode by using the 0.7 volt, now once you will get this circuit, so that is the question of analog or question of network? Okay. Question of analog or questions of network? This is analog and that is what? Network. Or network means what? KCL, KVL, mesh analysis, nodal analysis. Okay, right. Mesh analysis or what? Nodal analysis. So that is the question, guys. So if give me the answer. Without getting the command over KCL, KVL, mesh analysis, nodal analysis, Thevenin's theorem, superposition theorem, two-port network, is it possible to get the command over the analog? Is it possible? Not possible. Not possible. Okay. And that's why I am taking what? Super 3 subject. Super 3 means what? Network, then analog, and then what? Digital. Because digital, some topics of digital based on what? Analog. This is the start your preparation. Just I am giving you the hint. Start your preparation now. So yeah, you can solve it. Yeah, you can solve it and get the answer. Right? Okay. It's up to you. Please. I think you are getting, some students are getting 4.59, some are getting the 0.40. What is the exact answer? Less than 0.5, guys. Less than 0.5 will be the answer. But in a previous diagram, it was the 0.5 milliampere. When it is replaced by the battery, definitely the answer will be less than the 0.5. You are giving the wrong answer. If you are giving the 4.59 ampere, how is it possible ampere? Resistance in kilo ohm, then current will be in milliampere. And second important thing, it will be less than the 0.5 milliampere. Why? Because under ideal condition, we are getting 0.5 milliampere. Then under practical condition, definitely the current will be less. Because this voltage will oppose. And that's why the answer is what? You are giving the 0.4 something, then that is your correct answer. 0.4 something. Okay. Yes, you can check. 0.40 something milliampere. Okay then. Now, third diagram, guys. Third diagram. This is the second condition where we are replacing the diode by what? 0.7. Now, in some numericals, they will give you this type of circuit. That is the diode. It is forward bias. They will give this type of diagram. When it is forward bias, this is called cut-in voltage and RF. And when it is reverse bias, it will act as open circuit. Okay. If this is given, then what about the characteristics? This type of characteristics. Everyone, I am going to give you the question, then try to solve. This time I want correct answer. Now, this is the VI. Then that is the characteristics. Up to this point, it is a straight line, and after that, there is some slope. That is not a straight one. It has the slope. What is the resistance after that? This is called V gamma, cut-in voltage. And this is the I, this is the V. And the slope of this line is 1 by RF. Slope of this line is what? 1 by RF, I versus V. In that case, if this diagram is given or if this is given, then diode should be replaced by the V gamma and RF. RF is the internal resistance of the diode, guys. Right? Again, try to understand. This is again a piecewise linear model. How that is a linear? Because the diode is a non-linear device. But we are assuming it is a linear, it is a large signal model. Watch this. For this portion to this portion, it has the resistance what? Infinite. It has the resistance what? Infinity. And for this portion, it is a constant resistance 1 by Rf. It has the constant slope. That's why it will follow the Ohm's law. And piecewise linear. So when the voltage across the diode is less than V gamma, what about the diode? It is off. What is the resistance of the diode? Rr, that is infinite. When the V is greater than V gamma, what about the diode? It is on. And then the diode is replaced by a linear model, that is the V gamma and Rf. That is also given in the table. If suppose it is given, this is given, then how we can solve the same question, guys? Again, try to give me the answer for the same question. Same question. I am going to repeat it for the practical condition. Now you can compare when we are considering the ideal condition, what will be the change, guys? Okay. Now focus on this. This time I want the right answer. Okay, what is given? For example, this question is given. With this question that is given, this is the diode. This is the 100 ohm. Resistance value is 100 ohm and the cut-in voltage is given as 0.5 volt. If it will be mentioned in the question. It may be 0.5 volt, it may be 0.6 volt, it may be 0.7 volt. Let I am giving you the 0.5 volt for silicon. And what is the internal resistance of the diode? Let it is 100 ohm. Okay. Now when it is forward bias, and when it is reverse bias, it is act as open circuit. Okay. And that is the question. What is the question? Find I naught and what is the drop across the diode? You have to find. Find I naught and Vd. What is the drop across the diode? These are the two questions. So in initial question, what was the drop? 0. In previous question, what was the drop across the diode? 0.7 volt. This time you have to find a drop across the diode also. So what is the meaning of this? This is a very, very important one. Now guys, watch this. It is a 15 volt. Positive terminal voltage is greater than negative terminal voltage. That's why the diode is forward bias. Once the diode is forward bias, then it should be replaced by the V gamma and 100 ohm. That is the piecewise linear model. That is this portion. We are in this portion because the diode is forward bias. And then how we can solve this question? First of all, this diode is replaced by V gamma and Rf. And here one R connected. What is the value? 10 kilo ohm. What is the value of the RF? 100 ohm. First of all, convert it into kilo ohm. 1.1 kilo ohm. What is the value of the V gamma? V gamma is given as 0.5 volt. No problem. And this is from this portion to this portion. This is a complete diode. Remember, this is a diode from this portion to this portion. This is a diode. So when we are talking about the drop across the diode, this is the drop across the diode Vd. This is 10 kilo ohm. This is the 15. This is the 10 kilo ohm. Right now you have to find what is the current through the diode, means what is the current in this branch. Okay, easy guys. Now again you have to apply the KCL at this point. KCL means I1 plus I2 plus I3 is equal to 0. So we are going to apply the KCL. It will become Vx minus 15 divided by 10. Vx minus 15 divided by 10 plus Vx minus 0 divided by 10. Vx minus 0 divided by 10 plus Vx minus 0.5. Vx minus this 0.5 divided by what is the resistance? 10 plus 0.1, 10.1. 10.1 is equal to what? 0. Is equal to what? 0. Now this time that is the value. Now I am giving you the assignment. With the help of this KCL, Vx minus 15 by 10, Vx minus 0 by 10, Vx minus 0.5 divided by 10.1 is equal to 0. Find Vx. It is very easy. If you have the equation, solve it, take the LCM, right, and get the answer. Or you can also take the 10.1 as nearly equal to 10, so you will get the approximate value. You will get the approximate value of that. Okay, no problem. You will get the approximate value. But if you are considering the 10.1, then you are going to get the exact value of Vx. Once you will get the Vx, then what is the I naught? Vx minus V gamma upon what? Rf plus R. So the I naught will become current through the diode Vx minus V gamma upon Rf plus R. These two resistors are connected in series. First of all, get the Vx. V gamma is 0.5, Rf is 0.1, R is what? 10, 10.1. You will get the I naught. Okay. Then finally, what is the drop across the diode? That is the question. To drop across the diode means, always remember, this is the part of the diode. This is the battery and this RF is the part of the diode. And if you want to find out drop across the diode, always think about this diagram. This is the RF, this is the V gamma. What is the current here? Like this is the I naught, this is the I naught current. So what is the drop across the RF? I naught into RF. So what is the complete drop across the diode? VD. This VD is given by V gamma plus what? I naught into RF. What is the V gamma? 0.5. What is the I naught? From this you have to calculate the I naught. And what is the RF? 0.1 I naught. Check the drop. Check the drop here. What we are doing actually, we are taking the 0.7 volt as a fixed drop. But if suppose you are going to find the exact drop, that is a variable. Because when we are changing the value of that 15 volt supply, Vx will change. When the Vx will change, I will change. When the I will change, the drop across the diode will also change. So that is, I naught depends upon the supply voltage. And that's why the drop across the diode also depends upon the supply voltage. So this is the assignment for you guys. Find the Vx, and this time what is the exact value of I naught through the diode, you have to check. So I want to conclude it. I have discussed the three conditions of the diode here. First one, every new students, this is called ideal condition. Ideal condition means it will act as short circuit, it will act as open circuit. This is the IV characteristics of the ideal diode. Then second one I have discussed, already I have solved one question. Ideally it will act as short circuit. Then we have find the solution. That is a very easy, right? Then in second case, I have taken the practical condition that the drop across the silicon diode is fixed 0.7 volt, 0.7 volt. So once it is the 0.7 volt, we are considering we have solved the same question by replacing the diode by 0.7 volt. So that is, we have to apply the KCL, or you can also apply the mesh analysis or any other method to solve this question. Then again it is the value. Okay, then you can find the value. This is the value. Again we are finding the I less than that. Initially we are getting the 0.5, here we are getting the 0.4. Then this is the second condition. Third condition, in a numerical, if this is given V gamma and RF, then definitely they will provide the value of the V gamma, that is called cut-in voltage, and RF, that is called the resistance of the forward bias diode, and that is the characteristics, IV characteristics. In that case, again we are solving the question. Then in that case the diode is replaced by this, that is the numerical. Again apply the KCL. With the help of this, find the Vx, find the I naught, find the drop across the diode. What is the answer this time? 0.42. Salja. Okay. Salja, you are giving the drop across the diode is 0.54 volt only. Yes, it may possible that 0.54 volt. Yes. So if it is 0.54 volt means what? The current through the diode is very small, and just after cutting, this is, if you are getting the right answer, otherwise everyone please check this. I want to give you the hint. That is the characteristics. This is a very important one. This is the characteristics of the diode. This is the slope 1 by RF. 1 by 100, that is, this is the 0.5, this is the drop across the diode, and that is the I. Because Salja is giving the answer, otherwise you can check your answer, 0.42 milliampere. 0.42 milliampere is the current. This is the zero current. 0.42 milliampere means current is this one. And what is the drop across the diode? Here you are having the drop 0.542 something. And what is the current? 0.42 milliampere here. So current, it is in milliampere, and that is the drop, it is in volt. So this is the drop across the diode. So normally what we are calculating drop, if suppose you are not having the idea, oh, you are approximately consider equal to 10, then you are getting it is the approximate answer, guys. Because Selja giving the comments that I have taken the 10, not 10.1. Okay, 10 is, you are getting the approximated answer. Yes, it will work for you. But suppose you are getting the 10.1, then it will become very lengthy. Then you have to take the LCM accordingly, or you have to change the value, or that will become what, again, you can find. This will become what, I am just giving you the hint. No need to take the LCM. It will become 0.1 Vx minus 1.5 plus 0.1 Vx plus Vx divided by 10.1, get the value in point. What is the value in points, right? And then 0.5 divided by 10.1, get the Vx. Then it will become very easy. Then this, add these 3 Vx and add these two numbers, and finally you can find the value of the Vx. Very easy. Once you will find the value of the Vx, then you can find the value of the current from this. That is the exact value. No need to find the LCM, otherwise it will become very lengthy for you. Okay, got the hint? So again, try to understand. 1 minute. Once you get this diagram, this is not analog. It is a question of what? Network. Not analog. This is analog. This is again network. Then after that, mathematics, how to solve the equation, how to solve this fraction. Why only 17% or 18% students are able to qualify the GATE examination? Because they are not able to solve the questions from network. Basic question, KCL, KVL, nodal analysis or mesh analysis, and they are not able to solve the questions from what mathematics. They are not able to solve the questions on integration, differentiation, how to find the slope of the line. Already I have given in my first class, basics of the network. Watch that session, get the command over that. Automatically you will be able to solve the questions from analog. This is the question. Okay, find the value, exact value, and that is the graph, guys. Okay, in exam, if the student will ask what is the drop across the diode, normally they will say, sir, 0.7 volt. 0.7 volt is fixed for the silicon, but when we are giving this model, this is called piecewise linear model, like this, then always remember the drop is variable. V gamma plus this, V gamma plus I into RF. I naught is the drop across the diode, current through the diode, and that is the formula for the drop across the diode. Always remember, you have to find from this formula if this is given. If this is given. So any other suggestion, guys? So this is all about the values. Then tomorrow we will solve some more numericals on that. Till then, I am giving you the one assignments. Try to solve this question. Right? Now, very, very basic question I want to give you. This is the first question. Try to solve this question. Tomorrow I will give the answer for this question. This is the homework for you. Okay, what is the answer? What is this? Assuming the diodes are ideal in the figure, the current in the diode D1. You have to find the current in the diode, and as you know, in nodal analysis we are considering it as a common node, reference node. Then apply the concept. Then second question, okay, which diodes are on and which diodes are off? You have to find it. D1 and D2, there are two diodes. And in a 2020, that is the GATE 2023, similar type of questions. In GATE 2023, similar type of questions. Which diodes are on, which diodes are off in electrical branch. We will solve the same questions. Tomorrow we will solve same questions. That is another homework. Okay. Guys, I think you are enjoying the session. Any other suggestions? We are going to take very, very important sessions on that. Right, on app, I am taking one session. So tomorrow 11 a.m. you can join for the quiz, network plus digital, and then day after tomorrow at same time quiz on what analog. Okay, and daily at 7 p.m. I am taking the session. So on BYJU'S exam prep. So for more detail, join my Telegram channel, that is Electronics by Sanjay Rathi, so that you will get the notification about all my classes, and you can scan this code for our Telegram channel, guys. Okay, then thank you. Like the session and subscribe our channel, guys. Thank you and good day.